Welcome back to Catalyst Grid. I'm Kingsley Amufua, lead scheduler with DC Nordics. In episode 1, we defined the Brownfield brief. Today, we begin the detective work. We are moving inside the walls of Project VERTEX. Our mission is simple but massive. We have to rediscover this 12-year-old facility. We have to find the truth behind the original drawings. A brownfield site is a living archive. 12 years of operations mean 12 years of unrecorded changes, upgrades, and quick fixes. The building we see today isn't always the building that's on the 2012 blueprints. The unknown building is our biggest technical risk. A single unrecorded pipe or a structural shift can stop a 30-megawatt expansion in its tracks. We can't afford surprises when the live load is in play. To solve this mystery, we use a sophisticated technical toolbox. Digital laser scanning, ground-penetrating radar, and ultrasonic structural assessments. Let's look at the investigative process in detail. Phase 1 is digital laser scanning. We deploy scanners to create a millimeter-accurate 3D point cloud of the entire facility. Every corridor, every hall, and every plant room is mapped in precision light. This point cloud data is our foundation. It allows us to see exactly where every service is located relative to our proposed expansion. We are looking for the verified truth. No more guessing based on old drawings. Take this column, for example. The 2012 drawings show it center aligned. Our scan shows a 200mm deviation. In Greenfield, that's a footnote. In Brownfield, that's a structural clash we must solve right now. Phase 2, looking below the slab. We use ground-penetrating radar to map the subterranean world. Buried conduits, reinforcement bars, and hidden services. We need to know what's under our feet before we core. GPR gives us the map. Potholing gives us the physical certainty. We hand dig to verify critical services. Finding a high-voltage line with a digger bucket is a disaster we eliminate through discovery. We also use ultrasonic pulse velocity testing. This non-destructive method lets us see through 14-year-old concrete. We are verifying structural integrity for the new loads without damaging the existing slab. Thermal imaging is another critical tool. We map the hotspots on existing electrical gear while they carry the live load. We are searching for hidden stress points before we tie in the new capacity. Constraint 2. Existing structural loading. We are doubling the IT capacity, which means doubling the cooling plant. That weight is headed for the roof. We have to assess every single column bay's capacity. Structural feasibility studies often find original foundations overloaded for new plant. We measure deflection and calculate load paths. We strengthen the skeleton with local reinforcement before the first new chiller arrives. And then there is Constraint 12, asbestos. A building from 2012 may still contain legacy materials in insulation or fireproofing. Detailed surveys and lab testing are our only defense. We leave zero room for surprises. Licensed removal is baked into our 32-month program from day one. If we find it during the main works, the whole facility stops. By finding it now, we maintain the schedule and the safety of the site. Surveys aren't silent. Laser scanning and GPR require access and movement that can cause noise or vibration. We communicate every investigative step to our tenants via the impact register. We protect the racks. The ultimate deliverable of this phase is the verified model. We move from a world of maybe to a world of digital certainty. This model governs every MEP tie-in and structural bolt for the next 32 months. When you see the Brownfield signal, you know we've hit a point of discovery. These are the moments where our project controls are tested. What we find in the walls determines if the machine keeps humming smoothly. In investigations, the signal denotes a major as-built mismatch. It's our warning to the team to pause, assess, and mitigate before the live load is ever put at risk. Look for it every single episode. This is the duality of Brownfield, bridging 14 years of engineering history. We are auditing the past to secure the future capacity. It is the most authoritative phase of Project VERTEX, building the machine. It takes a different kind of scheduler to manage these unknowns. This isn't just about moving bars on a chart. It's about managing the risk of the unknown building every single day. This is precision engineering. We've scanned the corridors, radar mapped the slab, and assessed the steel. The unknown building is no longer a mystery. We have our verified model, and we are ready for the next massive hurdle. VERTEX is humming. Next time, we tackle the most dangerous activity on the project. HV substation replacement, replacing the heartbeat of the building without killing the power. It's the ultimate test of uptime. Don't miss it. My name is Kingsley Amufua, lead scheduler with DC Nordics. Join us as we build the machine in a brownfield world. Kingsley Amufua, your host, signing off. Do not forget to subscribe, like, share, and comment. Always keep the load live. Episode 02 complete. Project VERTEX investigations verified. Stay tuned for the journey. Kingsley Amufua, your host, signing off. Do not forget to subscribe, like, share, and comment. The machine grows. Building the machine in a brownfield world. Doubling the capacity, protecting the load, maintaining the SLAs. This is Series 3. The machine grows. VERTEX is underway. Join the engineering marathon. Kingsley Amufua, your host, signing off. Series 3. Project VERTEX, Episode 02. Let's build. Machine building machine. Subscribe, like, share, and comment.